Hey everybody, hello out there. Welcome to yet another Solace Office Hours. I am Aaron from Solace, back with you for yet another Solace Office Hours. It is September 30th, 2025. Hello from Ottawa, Canada. It's a beautiful day here. Good morning, good evening, good afternoon, wherever you're watching us from. Thank you for joining. And if you're watching the replay, yeah, thanks for checking this out. So today, I am going to be joined by our product manager, Andrew, to talk all about, we're going to get a micro integrations update. I'm going to bring him on stage. Hey, Andrew, good morning.
Hello, how's it going, Aaron?
Yeah, pretty good. How are you?
And everybody out there.
And everybody out there listening. Hopefully we get a few people joining. Yeah, thousands of people. That's right. How are things? How are you doing?
Start right here. Yeah.
It's been a while since we've done one of these on the micro integrations. I think it was September last year. I think we did one. So yeah, it's November. That's right. Yeah. So it's been almost a year since we've had an update. So I'm assuming there's quite a few things to kind of update us on and the progress.
It's going to be a pretty bad hour if there isn't.
Yes, right. Not much new, everybody. That's it's gonna be a much shorter.
Let's tell some bad jokes.
It'll be a very short episode. So why don't you just introduce yourself for the people that are out there and say hello.
Sure. Andrew MacKenzie, I'm the principal technical product manager. My primary portfolio is integration, and I lead the product management side of the micro integrations. I've been at Solace 7.5 years.
Oh wow, it's been that long.
Eight in March. Still considered the new guy, but hey, what can you do?
That's right.
I'm based in Ottawa.
I'm based in Ottawa. I was just going to say, yeah. So I'm in Ottawa. I'm actually moving to Toronto this weekend. So I'll be doing future office hours from down there. And something we always ask at the start of our office hours are, hey, if you're out there and you're live, you're listening to us live on LinkedIn or on YouTube or on the Solace community, put it up in the chat. Say hello. Say hello. Tell us where you're joining us from. Oh, we have one already. Hey, Gaurav. Hello.
Hey, Gaurav.
Hello.
How's it going?
How's it going?
Long
yeah,
time,
good.
Man.
Thanks for tuning in on LinkedIn. That's great to hear from you. Okay, so Andrew, while maybe we might get a few more people saying hello, but should we do? You got some agenda or something we're going to talk about? The things we're going to
why don't you throw out my slides there?
Yeah, can do. Srinas, hello from Charlotte, North Carolina. Hi, how's the weather down there? I'm assuming it's probably pretty warm and balmy.
Probably pretty nice, I bet.
Probably. Well, it's nice today. I mean, it's I think it's sunny and I think 18 or 19. So
yeah,
Fahrenheit. That's what, like 60, 66 or so.
Yeah, high 60s, mid high 60s. Yeah,
that's right. Yeah. Anyway, thanks for joining. All right, so let's add your screen here to the feed.
Right.
There we go. Yeah. So, take it away, Andrew.
Yeah. So like Aaron says, it's been close to a year since we talked about micro integrations on said office hours. And so, first I'm going to start off. Not everybody knows what a micro integration is. I'm not counting on every single person that came to the last one a year ago. It's going to be here today. So we're going to talk a little bit about what is a micro integration. And then we can see what's new. So there's a lot of new micro integrations themselves, like different services that we now have micro integrations for. And there's a whole new mapping and transformation capability. On the cloud, it is a no-code, a drag and drop interface. And we're going to take a look at that. It has some AI mapping assistant with it, which we're going to explore today. Cool. And then we're also on the flip side of that, on the developer side, we've released an early access for our micro integrations development kit, or MDK, and it's available on our community. I think that Aaron's going to probably post that link into the chat when we get to there, but it is available, and you can create your own self-managed micro integration just by building using our tooling and building a Spring Cloud Stream binder. So that's pretty awesome. Cool if you're looking to create your own. And then Sorry?
I was just gonna say, I know that even internally, like quite a few of our Solace field team, looking at integrating with customers' specific requirements, have been asking for this development kit for some time. So that's
Right.
awesome that we're making it. It's EA now.
Right. Yes, it is. And it does a good job. I'm not going to run through the entire build process because it takes a few minutes, but we're going to look at it and see sort of what it produces and stuff like that. And then there is a major change coming up in the way that we present our microintegrations on the cloud, and they're referred to as multi-flow microintegrations. Anybody who has experience with our self-managed, they're already multi-flow, so we're moving that multi-flow capability into the cloud. And there's a couple different reasons we're doing that, which I'll talk about then. But I'm on a dev server that hopefully I can show you the work in progress there and what they're going to look like when they come sort of around the end of October, early November, kind of thing.
Live demos.
Demos, no.
Andrew. So it's always roll the dice.
If you look at the URL when I present it, it's like staging, right? It's like it's not even a live environment. So right. I begged the development team for me to be able to show today. So
do you want to define what multi-flows are when we talk about them, or do you just want to tell them what they are?
I'm going to define it when we talk about it. I have a slide on that.
So I don't even know. So
that's fine. We keep you out of the loop. So a microintegration is essentially, think of microservices for applications. That's what microintegrations are to integration. So essentially, you have these small, independently deployable artifacts, loosely coupled with each other, that enable the connectivity and data movement of event enabling your various different sources and targets, right? So think of your other brokers like an IBM MQ or a TIBCO EMS, or a cloud broker like a SQS or Google PubSub. But then you also have databases, Postgres, MySQL, SQL Server, Oracle, that kind of thing, and change data capture on those. Various different services, file systems, cloud file systems like S3 or Azure blob storage, that kind of thing. So these are all sort of at the edge of your mesh that you would like to integrate with your event mesh. And the microintegrations provide an easy way to get those events either onto the mesh or take them from the mesh and publish them to their end targets. So let's take a quick look at that.
Before you, I just want it's an interesting anecdote. So last week I was down in Mississauga for a developer workshop, 2-day workshop at one of our big customers. It was a great event, kind of pun not intended, but yeah, we were talking about events, thinking event driven, and in terms of integration, kind of these were developers, so they wanted to write their own code, but oftentimes you just want to integrate it with an existing data source that you already have, whether that's some cloud service or an existing kind of maybe legacy system. But we started talking about database integration. They're like, well, how does that work? And I'm like, well, through change data capture. And most of the people in the room hadn't heard the term of CDC before. The concept of turning database updates into a stream of events, by essentially most databases have plugins now for kind of like producing change data capture. Like as you update rows or add new rows or whatever, these are emitted as kind of change events. And you can just put that now onto a Solace broker to help move that data to other databases or to react to them with your real-time microservices or whatever. So
exactly. And that is sort of the approach that we take with relational databases or document databases as well, is rather than sort of polling a select statement against the source, where you have to then maintain state and you have to figure
the delta,
because a select statement's always going to return the current data set, not the change data set.
That's right. Yeah.
And so the CDC is a better approach because it essentially event enables your databases rather than being static queries. Right. So that's our approach for the sources, and then the targets, because they're coming from the event mesh, So the unique part about a microintegration is that the Solace broker is always on one side or the other, right? So on a source microintegration, like let's say Postgres CDC, Postgres is the source and the Solace broker is the target, right? If I'm publishing to, say, Snowflake, then the Solace broker is the source, and thus the source of event driven, right? Because it is event driven, because that's what's on the queues. And I'm publishing to the downstream target, which becomes event enabled because I'm publishing from an event aware platform,
right?
Like the Solace platform, right?
Cool. Yep. Nice.
So if you think of the sources as liberating, right? So we're liberating your service data, like in databases and file systems and other brokers and other different kinds of sources,
wherever they are,
applications like SaaSes, and you're liberating that data by putting it into the event mesh, and then using the power of the event mesh and the linked brokers, you can then stream and filter those across your event mesh to where it's actually needed. So say I come in from, in this case, it's coming in from Salesforce as a platform event or as CDC on one of the objects within there. And then I decide where to make those available within my event mesh. I subscribe to them, and then I can use that as a source to publish to a downstream, like in this case, ServiceNow and Workday, although we don't have microintegrations for those yet. This is more representation of a pattern rather than.
It's a good slide. It's a nice looking slide.
Yeah. So the whole notion that you're liberating, you're then streaming and filtering, and then you're integrating that data from the event mesh to your targets is sort of what it's all about. And then, because we have the event platform with Event Portal and other things like that, you'll be able to, govern and then, provide access to this data. Excuse me.
That's all right.
Temporarily lost my voice. So yeah, you'll be able to then, provide guidance and access to this event data and your microintegrations. So if you think of the orchestration of this, a complete end-to-end pipeline is your liberated data that you brought from your source, and then how it's distributed across the event mesh, and then the eventual target or targets, because of course this is PubSub, that you can publish to. And so an end-to-end pipeline is actually at least two microintegrations, if you think of it all as microintegrations.
On-ramp and off-ramp.
Yeah, the on-ramp and the off-ramp. Exactly. I used to, when we first started this, and I was thinking of ways to talk about this, I looked for good graphics on on-ramps and off-ramps, and it sounds better than it looks on a slide. It's just
the one real advantage that Solace has in terms of kind of versus what people might think of as a pipeline, which is just maybe a linear point-to-point kind of flow from one end to the other, is that by having the Solace event mesh, our mesh of brokers in the middle, means you've moved the integration right to the edge, right close to your data source. And then the whole stream and filter thing means that, once the data is on the event mesh as messages, as events, that can go anywhere you have Solace brokers deployed, on-prem, off-prem, using our topics, using our smart topic filtering to move that data dynamically to wherever it needs to go, rather than a bunch of point-to-point integrations between, Salesforce and SAP, for example. It's just get it onto the mesh, and if you have multiple consumers, they all get a copy. And
yeah, I mean, that's exactly right, because it turns out that, performance-wise, if you think of a connector, right, microintegration is essentially the connector part, but then the lightweight transformation as well, right? And then the notion that it's decoupled from its, you don't go from Salesforce directly to, say, ServiceNow. You have the buffer of the mesh in the middle, right? And the decoupling, and you can add targets and sources later, right? So it turns out that the performance that you can get from end-to-end pipeline that's going across 4 different networks is not great, right? And so in this model, you essentially are putting your microintegration and your broker towards the edge close to the source that you're, in this case, in the slide here, sales source. So you have those all, as close as network-wise as you can, because the thing about a source transformation target integration is that it always moves at the slowest pace of each of those, right? So if the slowest is a slow publisher, then your whole pipeline is going to go that speed, right? So if you can push this stuff closer together network-wise, the faster you're going to get the performance of your throughput from source transformation target, right? Rather than saying, oh, I'm also dependent on this other ServiceNow iPad or SaaS that's on a completely different network on the internet, and I have to transfer that across, from my on-prem broker across to that, and then eventually publish to that, and that's all one big thing. You can use the power of the event mesh and the distributed brokers to efficiently move these from one end to the other. That's have the buffer of the event mesh in the middle.
It's the buffer, right? It's like take care of the kind of transport across different geographies, maybe where there's latency involved. We have queuing, our persistent quality of service. Yeah, if it was just one big long pipeline, then and it's all kind of synchronous, yeah, your overall performance is going to suffer, rather than more of this decoupled approach where the mesh in the middle kind of decouples the front and the back. So all good.
And the whole notion that you're only opening one pipe between these, right? It's the broker mesh connection, rather than figuring out how your Salesforce is going to talk to your micro integration, which is then going to talk to ServiceNow, right? That's a lot of different connectivity that you don't need to worry about with micro integration. They're very simple. They do ingress or egress. There's another type called a processor, which is intra mesh, but essentially they do a specific thing very, very simply.
Yep. Hopefully that's a good definition for everybody. We are all on the same page now.
Yeah. So let's talk about.
Oh, is it demo time already? All right, everybody.
It is.
Here we go.
Yeah, I don't do a lot of slides.
I think
so. This is the Cloud Console for Solace Cloud, and there's a micro integrations section here, and you'll notice that this is environment aware. So I have a specific environment for PLM demos. So I'm only seeing micro integrations within that environment.
Can you zoom in one click, Andrew? Would that mess up your formatting there?
Sorry?
Control plus. Can you zoom in one on your browser there? Or
okay. Is there a?
Yeah, just Control plus is the easiest way. Yeah. Oh, it's a bit better. All right. That's great. Yeah, that's great. Okay. If as long as things fit on the screen. This is my only job, is telling people to zoom in. So. Looks good.
I thought it was. I thought it was maximized. Okay. Cool. So yeah, so you can see that I'm part of a single. I'm part of an environment, so I only see micro integrations within there. And then if I go to the create, so these are the ones I already have authored. You can see that I'm not actually running any of them yet. We're going to look at this Postgres one in a second. But if I go to create, it shows the tiles of all the available micro integrations. And I would say, I don't recall exactly what was available last November when we did this, but let's just say that this is quite a bit more extensive now.
More extensive,
including
for sure.
New ones for CDC. We were just talking about CDC. So there's a Postgres, there's a Microsoft SQL Server. In the next month or two, I'm going to be getting 4 more. So MySQL, MongoDB, DB2, and Oracle.
Excellent.
So those are coming very shortly. I also have. I was talking about processors. So there is this transform processor, which is Solace to Solace, and what it allows you to do is take the messages from a queue that's already on the mesh and transform them into perhaps another sort of common domain model, or format, and republish them to the event mesh, which might make them better for sort of the conforming to a common model, or make them more appropriate for the egress. The other thing that it allows you to do
would those get republished back to the same broker, the same location, or could you have it going to a different broker, like maybe
it would,
bridging between two?
But you can then, of course, mesh. You could then you republish it to the same broker, but that topic could be subscribed to by a meshed broker, right? So you're still going to be able to get it on other brokers. But for performance reasons, you'd want to republish it to the same broker, right? So these can be quite quick because our broker's fast, and so if you're reading from the same broker and publishing back to the same broker, then they tend to be quite one of our more performant microintegrations.
If your microintegration is close to the broker, that should be a true statement. So
well, yeah, let me just quickly talk about that's a good segue. So the way that we deploy the cloud microintegrations on Solace Cloud is that they're deployed as a pod on a node that's directly in the same cluster as the broker that you're connected to. Right, so there is no network latency. Well, there's very minimal network latency because you're in the same Kubernetes cluster as it's deployed, and there's a direct relationship between the broker and the deployed microintegration.
Right, and so if you're doing self-managed, that would be our recommendation, right? Is to always kind of try to make sure that
people sometimes complain about the performance they're getting with the self-managed, and I ask them sort of where on the network is everything. And inevitably, if they're experiencing poor performance, they have IBM MQ on some private network. They have their microintegration runtime deployed on another network that's running Linux VMs, and they could even be publishing to like a cloud broker.
Right, that's a lot of hops.
that's a lot of network latency in between all those things, right? So I do suggest try to mimic as close as possible what we do on the cloud, and try to put everything as close as possible on the network as you can.
Yep. And
take advantage of the fact that you can, put a smallish broker beside your microintegration and then have it mesh with, a more sizable broker that you can subscribe to on another part, and rely on the mesh to be the distributor of those events. One of the primary use cases of the transform processor is because you can transform stuff on the way in with a source microintegration, but there's definitely stuff that's sitting on your mesh that didn't arrive from a microintegration, right? So you have, you might have some other application just publishing to your
regular publishers,
and you just want to take that and make it more the domain model or some other format. And so you'd want to take that, republish it, and then now it's sort of in the format that you need for your other downstream applications.
It's a great approach to kind of dealing with legacy publisher applications, and maybe you don't want to change the code on. You want to update the topic space or the payload or do something like that. Now, instead of having to modify your legacy publisher apps or write some custom code, which I've done to do transforms, now it's a little deployable, config-driven microintegration. I mean, that's
right. Exactly.
Really useful. Yeah.
So these are the available ones. We're going to take a quick look at one of the brand new ones, which is the Postgres CDC. So I have this one already started. You can see that it is going from Postgres database and an employees table. And it's publishing to my cloud service PLM demo, which is a broker service that I have in AWS, and it's publishing to this topic. Now, chances are that your source is, because it's a database, it's going to be flat, right? So I've already imported the representation of the I've already imported what the source payloads look like. So I'll show you. I'll re-import this. So
flat meaning like it's just a bunch of columns, right? I mean, it's
if you think about it, a table is exactly that. It's a series of columns, right?
Columns,
and so there's no structure. So even though you are probably the format you probably want it in is something like an XML or a JSON. And currently, I will mention up front here that we currently only support JSON payloads in the transforms. So but we are adding other formats later. But right now, so you need to sort of take that flat thing, and you'll see my target in a second. It's not. It's nested JSON in the way that you would expect JSON to be, with parent objects and then sub keys and stuff like that.
We actually have a question from the field here, Andrew, all about the transform processor, actually. So from Arnaldo here, do you think message transform based on frameworks like Jolt or XSLT would be a good idea?
It's likely not going to be part of what we do. So if you think of other integration platforms, like Mule has data weave. Each of the different integration tools tend to have their own sort of expression language. We are using and you'll see it on the self-managed. We are using a variation of Spring expression language. And so the facilities that Spell brings to the table, we're augmenting it with our own functions, and then you're essentially coding in Spell. And there's no real opportunity for us to bring in those other capabilities. But I will say that we are looking at adding a scripting module to the transformation, so that in a function, you would be passed certain, whatever the input data is, and you would have an interface for passing the output. But in there, you would do something like a Groovy script or a JavaScript script in there, which could have a lot more custom logic in it than you're going to be able to be doing through our drag and drop interface.
Cool.
So that would be, so we're not looking at those other types of transformations, but we are building on what you can do in Spell and our extensions to Spell, if that answers the question.
Cool. Thanks, Andrew. I will just say a quick anecdote that Solace, in its very early days, Solace actually started out as an XML content router. Our first production brokers that we used to ship were XML, and built into hardware, because originally we were just a hardware company. We had a blade that did XSLT transforms in hardware, in firmware. It was all FPGA based. And so as a content router, rather than subscribing to topics like we do today in modern Solace, with our slashes and stars, it was a XPath subscription. So as a subscriber, you had an XPath subscription, and if it matched, you got the copy. And we actually did XSLT. So if you're like a mobile device, it would give you maybe a slimmed down version of that full 100K payload. So we have some history there with XSLT, but not today in the product. It's not built in.
Well, you can use XPath in your. You can use XML as input to your SFTP, so your files can be in XML format, and you can tell it what the repeatable part of those is by using XPath. So there's some limited sort of use of that within it. So what I'm doing here is I'm importing a JSON document that represents what's in my payloads. So if I import that, you'll see that it's brought in this. So what comes out of our CDC is a payload that has this as the parent object, and then the actual columns within there, right? Okay. So there's all the common columns of an employee here, and then on the target, I have a more sort of business-centric format that has a bunch of objects like contact info, personal info, org info, that has the nested objects within it, right? And so I would prefer the output to be the one that I store on the mesh. And so one way I can do that is I can look at this blank slate right now and say, well, I could map them all manually, but wouldn't it be cool if I could map with AI and let it figure out some of the things that it might do? Now, I think that we're not. I'm going to do this without any kind of hints at all, and let's see what it comes up with.
Let's see what it comes up
with.
So you've taken the
30,
database,
25 seconds or something like that. So we'll talk through this.
So you've imported the column format. This is these are the columns and the values that we're expecting. It's just flat, and you're like, this is how I want it to look. So on the right hand side there, you've kind of defined the kind of nested JSON object that you want as your output, based on whatever requirements or kind of standard format you want on the mesh. And and so
the whole purpose of the transformations is to make whatever I have available on the source look like the target, right? My goal here is to map the target. so that it's as complete as possible.
Right.
So the AI came back. So what I was doing there is we have a big sort of prompt in the background that's been constructed, and it knows about all the columns that you have, and it knows about all the functions that are available within our expression language, and the knowledge of it being, I think it's Sonnet 4 under the covers that we're using. And so what it's done is it said, I'm looking at your input and I'm looking at your output, and I have some pretty good ideas about how I should map all these. So some of them are just simple straight mappings, like
first name probably, or
ID to ID. No,
okay.
We're going to look at first name.
Oh,
so ID to ID and email to email. But if you look at the full name, so if you see the target is a full name, it's not a first name or a last name. And if I look at this transformation, it's properly figured out that first name would have a space between it and a last name. It's using the concat function, and it's producing a full name.
That's cool.
Right? So
in the West, sometimes
that was AI inferring that most people want first name space last name.
Yeah.
Right? But, and then, it's done some other ones, but that's the key one that it does. But what if I actually had different needs, right? What if I want full name should be formatted as last name, comma, space, first name.
Right, which is quite common to sort things and whatnot.
Yeah, which is common because you want to have the alphabetical thing as your first, right? So that you put the last name first. And then what if I don't want to show the salaries? So salary should be masked with 5 asterisks.
Okay.
Right?
Yep.
Is that what I did? Oh, those are. Oh, no, I did.
Those are quotes. A bunch of quotes.
Yeah.
Shift.
Forgive my vision. I've had eye surgery recently. Okay, so now I'm taking that, instead of just letting it do its default, I'm actually giving it some extra context for some of the ones that I want kind of special. So then if I click on the mask, so it's now augmented that original prompt that we, it's opaque to the users. It's very long, and we wouldn't necessarily want to show that, but it's augmenting it with these extra context that I've typed in myself, knowing my own data and knowing that it would be great if the AI used that context to do different mappings and make it more accurate.
Just as a curious question, I mean, is this AI transform using the Solace agent mesh that we are developing under the covers?
No, it's going directly off of Sonnet 4.
Okay,
it's submitting it directly to that because it's not a.
It's very specific.
It doesn't need an agent because it knows how to. There's no orchestration required here. It knows that this prompt is going directly to this.
Makes sense.
To this model, right? So now if I look at full name, you can see that it has put last name, comma, space, first name.
I figured it out. Yeah,
and if I look at salary,
the transform there.
It is salary. It's and it's masked it with the 5 asterisks.
Yep. Cool.
Right. So then,
on your little wire diagram, anywhere there's an FX, that means there's an active kind of transform process.
Yeah, and if I want to add something, like say I want, I probably want, let's say I probably want. Oh, what did it do with age?
Oh, age is getting transformed.
Oh, it just converted to a string because my target was a string. But what if here's a good one. What if I actually wanted to mask that? Right? Because I don't want everybody to know everybody's age. Right? So
we'll keep that secret.
So if I mask that with the asterisks again.
So you can do this fully manually if you wanted to, right? That's
yeah, I could. Everything that was done, all those links, I could have done manually. But keep in mind too that if I have something on the target that I don't map, it won't appear in the output.
Right.
Right.
Makes sense.
Like it doesn't have a value, so it's not going to
Yeah.
appear in the resulting payload. Right.
Unless you tell it maybe to kind of derive it from some combination of sources or something, and tell it how to do that, I guess.
Yeah, but that's then you're making a transfer from the source things.
Right.
Now, it's not just payload items that we have in the source here too, right? So keep in mind we also have the ability. So the AI created this constant, which is the comma space. But I can create manually my own constants as well if I want to use them within my as parameters within my or as data within my functions. There's also what we call dynamic values, and there's only 2 available right now. But basically, it's an epoch time or a current date time. Okay. This will get evaluated at transformation time as current timestamp, or the seconds since 1970 01.
Yep. Milliseconds since 1970 January 1st.
And this is really useful. So the seconds since epoch is really useful for our so several targets, but specifically it's useful in the Salesforce platform events target, because one of the schemas objects that Salesforce requires on publishing a platform event is a timestamp in epoch in the epoch seconds, right? So this is a good way. I mean, you could hard code it too, but that's not very useful for your application. So this will actually add a real dynamic timestamp to that at evaluation time.
That's cool.
At runtime.
From the Solace perspective, is that added as a field in the payload, or is that actually setting the message, like the send timestamp on the message metadata?
Yeah, in that case, I was actually talking about a Salesforce target, so it's actually adding it as a payload item within what we're sending to the Salesforce API.
We have another question here from Arnaldo asking about interested in this map AI function. Would it be available as a REST API to include in a CI/CD pipeline, for instance?
That is a great question. Everything that you see here, with the possible exception of the map with AI, is available through our REST API.
That's right.
Right. So I can do everything here. I can map. I can create all my source and target information.
Everything in the event portal. Everything you see here, including even deploying brokers and stuff, can be done with our REST API.
No, but this is the V2 API just for microintegration management.
There's a
so
specific one.
Create, edit, delete, deploy, undeploy, all the microintegrations through one of the V2 REST APIs, right?
Cool.
Just as we do for most of, you can do the same thing with brokers and stuff like that.
Is that documented at api.solace.dev along with the other mission control ones? Okay.
Yeah, it is.
Now,
it might still be marked as a beta because we're still adding to it, but it is fully usable, and it is what this is using in the background, by the way.
Right.
The UI uses the API in the background.
Yep.
So we know that it works. But
this specifically, this map AI,
whether or not the map with AI is available, I doubt it, because it's a separate microservice that we run. I can see whether that's feasible or not. I will say that there is a configurable limit to how many AI queries that we're going to allocate to a customer. And so if it's done through an API as a CI/CD thing, I think we have a bigger risk of overloading that. So I would be hesitant to say that it probably won't make it into the REST API. But
I would think that the AI thing, you kind of want a human in the loop to kind of see what the AI did and maybe tweak it a little bit, right? But
that is our advice, is to take a look at the mappings it did and make sure that it's actually what you wanted.
But in terms of defining all these things, like, all the definitions can be done manually, right? If you could build that into your pipeline. So I know, here's my source, here's my target, and using REST, I can build that thing. Once I know what it is, then all the rest of the stuff is available by the API.
Yeah, so I just wanted to point out the other thing is here you have headers, right? So these are provider-specific source headers. So in the case of the Postgres CDC, there's like a header what's the database name, the schema, and the table name that it came from. And you can use these as like dynamic things, right? So for instance, we have this thing called the Smart Topic Destination, which is a dynamic publishing endpoint, right? So instead of the static endpoint that I had, which is employee CDC departments, I might actually want to have that more dynamic, right? Maybe I want, maybe I don't want to hard code the name of the table in, right? So if I have a topic string that is,
oh wow. I mean, this is something that we when we do our training, it's one of our big value props is, use Solace's dynamic hierarchical multi-value topic structure to be able to, if you're publishing everything into one topic, there's no way to do any filtering. You kind of have to take that full feed
right,
of that one topic versus being able to subscribe to parts of it based on the
so
topic
so you can use the headers. Or,
cool.
And the other thing is you can use parts of the payload too, right?
Sure.
To create this dynamic topic string that you want to smart publish to.
If you have a unique
so maybe
ID
there's
or
a variable to some of the properties that you're doing. So maybe it's always, employees / whatever the action is, like import or whatever. And then your properties, the different levels of your topic are dynamically driven from the source data.
Like
right?
Office location or maybe department,
Yeah, like I have a couple of them down here that I typically use. I usually use like department, right? That's a level. And then usually I use one from the like maybe the table name, right? Where you're getting some from the properties and you're getting some from the headers and some from the payload.
Cool.
Right? Which is useful. You can also add your if it's a user header capable source, like a broker, you can add your own headers here. So these are the user headers like foobar and stuff like that, right?
Right.
So that you can add your own levels as custom headers, as long as you know that your source is going to be producing those headers, right?
Otherwise, you might get some nulls in your topics.
Exactly, right? So. And so you don't want to do that. And then we have a very convenient function called join, which instead of having this, concatenate, this field and then add a slash between it and then this field and another slash, you can just say, I want to take these 4 fields, join them together with a slash in between. And that makes your topic strings that much easier.
That's awesome. So then if you want the full feed, you just use stars, wildcards on the subscriber side to get that full feed. And if you only want to listen to one specific department, then you just, you subscribe to that one department with your topic string. So there's
exactly right.
The filtering
so that brings out the magic of, by publishing to a proper topic hierarchy, you can then open up the filtering to your subscribers.
That's right. Yep.
So I was going to run this, but let's not run it because we probably don't have time for that.
We're about 15 minutes out here. So
we're almost out of usable time. Spent much longer on the transformation than I probably would like to. Okay, so let's go back to my agenda. What was I going to talk about next? We ad nauseum talked about mapping transforms. So
I guess the demo we just would have seen you would have published a message over here and it would have popped out over there in a different format, right? That's what we would have seen on the wire.
That's what we would have seen.
We can imagine that it works. We'll take
it.
Yeah,
I was going to publish these 5 insert statements and then and then subscribe to it on the other side, but you get the point. It will do that transformation, and the target payload will look exactly like you would expect it to.
Is there like error detection or like things like that?
Oh. Of course, I already prepped, and so you can see that. So my salary was masked. I have Williams / comma space Michael, right? So as I took these employees and I put them through the transform, they came out on the other side, on the Solace side, in the manner, and it's nested within the contact info and the org info and full name, right? Or the different sort of parent objects, right?
That's cool.
So this is
phone
the
number.
output of
You
what the input was, those other flat columns.
For your phone number there, just as like, I mean, could you tell the AI like make this into like an international kind of standard looking phone number with like +1,
Yeah, you could. And the
thing?
other aspect is there's just added a function that is mask. What do we call it? Mask character, which allows you to do the credit card thing where you say, I'll leave the last 4 digits,
the last 4
unmasked, or I could be the first 4, or and you decide which ones are going to be either the beginning or the end, and how many are unmasked. So you can do that as well.
That's cool. So it's JSON today, but XML is in the pipeline, right? For
XML should be in the next couple of months, and then we're looking at other formats after that, like probably Avro and CSV and stuff like that. So
of course,
stay tuned.
There's still a lot of XML out there flying around. So
yeah, I know. I hear from customers already. So for sure, I'm aware. So let's talk about the MDK.
Yes.
So can you throw up that that URL?
I have a few things. So by the way, just as a resource to kind of go and look what all of the different into micro integrations that we support, probably the easiest place to go would be to head over to our integration hub. And I'm sure if you just typed in Solace space integration hub into Google, it would probably point you to this specific link here. And this is so you don't actually have to log into the Solace Cloud console to see that kind of view with all the tiles that Andrew had. This is more of our kind of documentation page, I guess, on all the different MIs that we support, including what the kind of commercial considerations are for each one of them.
So the integration hub shows you not just micro integrations, or not just because some of the micro integrations that are available are only available self-managed. Like there's a couple of them that we've done that are only self-managed and have not yet made their way to the cloud. So the integration hub is really the superset of everything that's available, but it also talks about things like
RDP stuff.
We have a connector for SAP Integration Suite. We have a connector for MuleSoft. We have a connector for Boomi, right? So things that aren't pure, framework-driven micro integrations also appear on the integration hub as other types of integration.
There's lots of ways to integrate. There's lots of ways to integrate.
Plus we have the broker integrated ones, like the RDPs and stuff like that are also on the integration hub.
That's right. And if you want a bit more of a kind of a thorough kind of discussion, more or less what we've talked about a lot here, on our products page, there is something that talks about micro integration, our approach to kind of event-driven integration with integration towards the edge. But yeah, I'm going to put in a rather long URL into the chat here if anybody's curious. And that's what I think Andrew is going to show us about the MDK.
Yeah, but actually, before we move on, I just see the question over here about... Can you highlight that question?
Yeah, well,
right. So I like the Hi,
Writing Roach. It's one of our longtime listeners from Hong Kong. How's it going out there? Good evening. Hope it's not too late.
Yeah. So we all of the micro integrations that are available on cloud are available as self-managed, and like I said, there's actually additional ones that are available only self-managed. And the way you deploy those is on your own infrastructure, thus the self-managed aspect of it. And they can be deployed as simple Java applications, so Java -jar, or they can also be deployed in VMs as Java -jar, or Docker containers, or the containers within an orchestration like a Kubernetes or a Swarm. So they're essentially stateless Spring Boot applications that get deployed using the configuration that you choose with our framework and the 2 data access points, which are Spring Cloud Stream binders. Okay, so the architecture of a micro integration, even if it's on cloud, we're just generating configuration there. You have a Spring Cloud Stream binder as your consumer. You have our framework in the middle, which manages acknowledgements and transformations and all the stuff that you need for like health checks and stuff like that. and then you have a target Spring Cloud Stream binder, which is the publisher. And one of those is always going to be the Solace binder, and the other one's going to be the other technology. And when we get to the MDK, which we don't have a lot of time for, it'll be that. And what you're looking at right here, this is now self-managed. You have to become more familiar with YAML, right? So the way you configure these is through an application YAML file. We are looking at the concept of authoring on the cloud, exporting the configuration, and then using that self-managed. But that's a sort of roadmap item. We'll get to that as soon as possible.
Yeah.
But in the meantime, you create your configuration in an editor here, like VS Code, and you define what your source is. So again, this is the same microintegration, but done in a self-managed way. So it's the employees table, and I'm publishing to a Solace topic. Turns out that's a different topic. And then here are where I define my transforms. So I haven't got all of them here, but essentially, if you look at the full name, this is what I was defining in that visual drag and drop interface, which is full name, which is joined with a comma space delimiter, and I'm joining last name and first name.
Just make sure you get your spacing right for YAML.
Yeah, it is a little finicky because it's YAML about spacing, but yeah, we are looking at the ability to export out the cloud config so that you can use those nice visual tools to author these things.
A follow-up question from Running Roach here. Just so to our users, we can state that similar to how we have connectors deployed as self-managed solutions, you can integrate these micro integrations as smaller Docker or on-prem Kubernetes into the farm.
Yes. That is the micro integration is a pattern. It's not just a product line, right? It's a pattern, and the pattern is these small, loosely coupled, excuse me, which always do something to Solace or Solace to something, right?
We don't call them connectors though, but they kind of are.
Well, so what you're going to find is, unfortunately, is that you're going to find that on self-managed, we use the word connector a lot because the product names all have connector in them. And because they're now Docker images that you can pull off of Docker Hub.
It's baked in. That's right.
We can't change those names, right? So you're going to see a lot more of the word connector when you're dealing with self-managed, but essentially micro integrations and self-managed connectors at Solace are the same thing.
Same thing, yeah.
Okay. Sorry, another question. If we have, say, 100 different queues.
I'm supposed to read the questions there, Andrew. All
okay.
Right, sure. 100. Yeah. A lot of different queues to transform. How do we manage the 20 workflow limit, having many Java container processes listening in a competing consumer pattern? I'd assume it's a one-to-one mapping, right?
You would just deploy them as multiple micro integrations.
Yeah, so you'd have 100 MIs more or less. That's roughly.
No, so that is where we're getting to the multi-flow. So maybe I should skip. Maybe I should skip the MDK today.
Well, just let's talk about it at least for a minute or two, just so people know where to find it. And
yeah,
you made a post on our Solace community, so if people are very interested in the micro integrations developer kit, it's all there. I'll push this link into the chat now. How about that, Andrew?
Yeah.
Okay.
So this is what you get with the MDK, and it's in an early access right now, so it's not complete, but it does work, and it's quite useful. So this is the README. So essentially, what you're doing is a micro integration is this middle part here, and what it consists of is like I said, a Spring Cloud Stream binder as the source, our framework in the middle, which does the transformations and all the sort of application facilities, and then a target Spring Cloud Stream binder for the other side. And what you're creating when you create a brand new micro integration is a binder to represent your service, right? So the thing that we don't have out of the box for the MDK is your data access. So you need to write a Spring Cloud Stream binder which is a common thing to do because Spring provides documentation for this. It is a known sort of thing to write a binder. We have one or two different methods that you need to, or classes that you need to implement. But other than that, it's essentially just a straight Spring Cloud Stream binder, as you would see on any Spring tutorial, right? And once you have that binder, then we provide all the tooling to bring those all together, build them into a deployable microintegration, provide some tests, build it into a container image if you want to, and then allows that to be deployed as your custom microintegration. Now, at the moment, those are only for self-managed. Like, we haven't done that extra step where you would then take yours and make it available to us or deploy it on the cloud somehow. That's a missing step. We'll get there, but right now, when you create a custom microintegration, it's only for self-managed.
How would that be? Like, would you certify it somehow, or would it just be only for that one customer?
We're still working on exactly how we would take user code in. We would probably have to certify it.
Danger.
Because you got to remember too that that's other people's code running within our own managed clouds. So there's some security issues there. There's some code quality issues that we'd want to take care of, right?
Yeah.
But for now, it's for you creating your own self-managed.
Real quick follow-up from Running Roach. He was just asking what is that 20 workflow limit that Arnaldo was referring to? Yeah.
So
I didn't know that. Is 20 the default, and you have to buy more to get more?
20 in self-managed is the total number of total number of flows that you can have.
Right.
If you think of the microintegration as the parent, the container that these things run in.
Okay.
Each one of the flows, let me go back to my application YAML there.
Oh, is this via SSH?
So you can have, in self-managed, we call them workflows. We call them flows, essentially. This is workflow 0. You can have 0 to 19 of these. And each one of them defines a endpoint to endpoint with possible transformations in the middle. And you can have, like someone pointed out, you can have up to 20 of those per parent microintegration, per runtime.
Okay.
And so what I was saying is, if you need 100, you would need to deploy 5 different microintegrations. So 5 of the parent objects, and then have 20 on each within that.
Interesting.
And that was kind of done intentionally because we were trying to go for a microintegration is a sort of a tight sort of related kind of thing. You wouldn't want to have it's not like a Boomi Atom cluster. It's not like a Mule runtime or a Kafka Connect cluster. You're not sending all of your things to that one thing, to that one microintegration and having them run across your entire thing. These are intended to be, like we said with the edge, they're intended to be put close to where your brokers are and close to where your targets are, your sources and targets are, right? So the notion that you would have, upwards of 20 related.
Related, I think, is a keyword, right? You want them all kind of similar because
it's the related flow aspect, right? Yeah. Is that because these are specific to a type, right? When I'm deploying a self-managed microintegration, it's an IBM MQ, it's a TIBCO EMS, it's a Amazon SQS, it's a Snowflake. Yeah. There's only one provider in there. You don't have a microintegration that's both IBM MQ and Snowflake, right? Those are deployed as separate runtimes. And so the chances are you're going to have sort of related flows within that one. And if you have more than 20, you just deploy a second runtime. Yeah. Now it's more infrastructure to manage for sure, but we didn't think that expanding it sort of beyond 20 was what we were intending with the sort of small targeted kind of runtimes that we were looking for.
That makes sense. And I was going to say, like, kind of related, not just in terms of the target or the source, but also like if you needed to make a change to this application, you need to change this YAML file and restart. Like all 20 flows within this one thing would all restart at the same time, right? Maybe you don't want that, so maybe like 10 in one and 15 in another and 3 in another, and like those are kind of grouped as a single unit of integration, right? So if you had to make changes or change one, they're a bit more independent, I guess, of other ones.
Right. So
at least 5. At least you need at least 5 to do 100 queues.
Yeah. So you can see that as I started typing, the one AI the Copilot has decided that it knows what I want next, and so you can add 0 to 19 here as different ones. Now, which is an interesting segue into what I do want to sort of quickly get to. Do I have any time? I don't have any time, do I? Okay, I'm going to quickly.
We can cover it quickly. Yeah, just go.
Yeah, if you have, if you.
I always run over. It's my.
So this is cloud. So you already saw that self-managed microintegrations are multi-flow. There's 0 to 19 of those flows. On the cloud, though, the way we currently deploy is exactly this. Every microintegration is a single flow. And every time I have a new microintegration, I'm deploying a different, it's a different pod on possibly the same node, but it's a different pod within Kubernetes, and these are totally isolated from each other. But just like Arnaldo was saying, we do have the notion that you have similar microintegrations, right? So similar flows. And so what we're introducing onto the cloud is bringing that multi-flow into the cloud. And so instead of every pod being its own source connection information, target connection information, and only one flow, you're going to be able to author, depending on how large you need to deploy it, 5, 10, or 20 flows within a single microintegration. Okay. And so this diagram sort of just kind of explains it. I only define my connection information to SQS once. I only define my connection information to Solace broker as the target once. And then I can have, between 1 and 20 flows within there. And the only difference between these is because I'm separating them out, I have a different source endpoint, a different target endpoint. So this is a different queue, let's say. And then this is a different topic that I'm publishing to. And then because it's unique, I can apply a different transformation to each one because, this incoming schema is going to be different from this incoming schema because they're different queues, right? So, so that is what we're looking to deploy. And it also gives you the opportunity to scale your runtimes with the flows. So there's 3 different node sizes, MI nodes, which is you can deploy, 1 through 5 flows to a small. You can deploy 6 through 10 to a regular, and 11 through 20 to a large. And these runtimes then we allocate more compute resources and more RAM. And so you can scale up your deployment, because the fact is a 20 flow microintegration isn't going to run well on a small runtime. Yeah. And so we kind of scale up the runtimes.
Unless it's really slow message rates or something. Unless it's very slow.
Because you get all 20 of those threads contending with the same relatively small CPU limit that's on a small MI node, right? So, as you scale up, as you need 5, 10, 20, you do pay extra for that. Like, it does cost you more, but it does allow you to then have more resources available for those 20. But, you could, if you really want to, you could break up the 20 into 4 smalls as well. Like, you don't have to deploy to the larger ones, but it ends up being the same cost-wise, the same thing, because they scale, in the same way that cloud compute resources, there's no benefit cost-wise to having 2 CPUs twice than 4 CPUs, right? They cost the same. And so that's the way that we scale up here.
And I guess these sizing considerations will be the same for on-prem, right? Like basically as the number of flows increases or the volume of data increases, you'd want to kind of give it more in your Kubernetes cluster or whatever, more compute or more processing power and stuff.
Yes.
No.
Yeah, and there's actually a situation where if you have a super high volume one, like maybe you have your orders queue
sure
is very high volume, and perhaps you're not getting the performance you need on a small, you can choose to deploy that on a regular, which gives you twice the compute power.
Right.
Now you do pay twice as much, but it might give you the more performance that you need.
Because that Solace, that pipeline essentially is multi-hop, right? So it would benefit from adding extra threads and CPUs.
It would benefit from every one of those flows is a couple of threads within Java, and they're being maintained. But the more compute they have, the faster they'll go, right?
Of course. Yeah.
So this is just a I know I'm out of time. This is a quick sort of view of what the multi-flow are going to look like within the cloud. So on the one hand, you create your, maybe edit doesn't work. Sorry. So you define your 2 sources, your 2 connections. Your source connection, in this case, it's a Solace broker, and my target is an IBM MQ queue manager. And then I define, 1 through 20 flows here, and that's only. Here's the edit doesn't work. That's only the endpoint information. So this is like say flow 3, and it's my customers queue, right? And down here, I would say it's it's my customers queue or something like that, and then I also define where I'm publishing it to. So I'm going to publish it. I'm going to be doing point-to-point to a MQ. So customers.queue from Solace, let's say, right? So that's where I'm publishing it to on the MQ. And then because the endpoints are different and unique, you have the opportunity to have different mappings between the different flows. I'm not going to do any right now. And then what you see is it's created a third flow. And so now all 3 of these flows are going to get deployed at the same time with this micro integration, which has these common connections to the source broker and the target broker in this case.
That's cool.
Right?
Nice.
So whereas before you would only be able to define a single flow within, this model allows you to have, like I said, if I have less than 5 here, it'll deploy on a small. And if I have more than 5, then it will deploy to a regular, and then so on.
And it's a nice GUI interface for constructing these things rather than hacking out YAML, although a lot of people do like to write their own. So yeah, having that export feature for self-managed would be quite a nice feature for people.
We have the drag and drop, transformations. I still get people saying, well, I'd like to just type those in, right? So, you have people love CLIs, people love GUIs.
I love CLIs.
I think there's a constituency for both.
Yep, 100%. That's awesome. Is that the end of our content? No, that's all right, Andrew. Like we always run a little bit over. We got some good questions today, and we had a lot of things to show. Yeah, thank you everybody out there for listening, and thank you for the people tuning in live and asking us some questions. That was great. We're always happy to answer questions live on Aaron's office hours. Andrew, thanks a lot. I guess we're not going to see you today at the office, but I'm next time I'm in town, I'll be I'll be coming up to Ottawa. It's only a 4-hour 4-hour drive or so. But yeah, next time.
Well,
whenever I come
you
to
know, you're
Ottawa,
moving to Toronto, so go Blue Jays.
it's not that. Oh, yeah, Global Blue Jays. Yeah, they're doing well. It's not the Leafs. I'm not going to cheer for the Leafs, but
No,
Blue Jays,
don't
yeah,
choose for the
so.
Leafs. No.
All right. Thanks, everybody. See you next month. We're going to be doing an update on our Solace Agent Mesh, and we're going to have the product manager for there, and it's going to be great. So check it out. I'll see you at the end of October. See you, Andrew. Thanks.